Vim. It's one of the most powerful and feature-rich editor, and a lot of people find it quite intimidating to work with Vim. But if you master some of the keys and shortcuts in Vim, that will go a long way and make you more efficient as a programmer. So in this video, my goal is not to show you everything that Vim offers, because that would be an information overload and you will not be able to retain it just from a single video. But my goal is to logically give you some tricks and patterns and some shortcuts in a way that you will retain the information once you finish watching this video. And if your intention is to appear for these exams CKD or CKA, then you probably know that you will need to interact with Vim editor. So in that case, knowing these kind of shortcuts will definitely make you more efficient and save you some time in your exam. And it's not just limited to these exams. If you learn these shortcuts, you can even use them in your day-to-day job, or even like add plugins for Vim in your other IDEs like VS Code or JetBrains. And you can essentially make use of these keys and shortcuts in those editors as well. So I just generated this fresh file from an imperative command, and this is the file for deployment definition. And we're going to practice our Vim shortcuts within this file. Okay, the way we have organized it is, first we'll take a look at all the modes, all the different modes of Vim editor. Then we'll take a look at how to navigate efficiently. Then we'll take a look at how to edit efficiently. And finally, we'll see how to save and exit. So let's start with that. In the modes, we have 4 different modes. The first one is normal. Then we have insert, visual, and lastly we have replace mode. Let me clear the board and let's look at each of these modes. So in the normal mode, all your alphanumeric keys behave like the operators or motion keys. So they are basically used for navigating around, and you will not be able to type anything in normal mode. Once you enter into the insert mode, your alphanumeric keys can be used as normal, and you will be able to type the text or numbers. Then we have visual mode, and in visual mode you can select the text without the use of mouse. And lastly we have replace, in which you can basically replace already typed characters with the new ones. So most of the time we will be spending in the normal mode initially, and normal mode is the default. So when you actually start the Vim editor, when you just create a file and you are going to be dropped in the normal mode. In the status bar you'll see this is a normal mode, and if you hit I, you can see now you are in insert mode. So in normal mode you can use the keys J, K, L, H to go up and down, right and left. And you can also use your cursor keys, but usually for the sake of efficiency, because your right hand fingers are always placed on J, K, L and colon keys, that's why you have these shortcuts like H, J, K, L, which help you navigate around. And I know it is quite confusing, and initially when I learned, I was very confused. So what helped me was to think of J like a downward pointing arrow. Because of the shape of J, it is downward pointing. Similarly, if you rotate K, it becomes like this, and you can imagine it to be facing upwards, and actually K.
Hello, class. To a bunch of lectures in the Kubernetes deep dive course on A Cloud Guru. How do I
everybody, my name is David and I'm certified in CKA, CKAD and CKS. Resources, for example, the Coda website, and you can see that there are 3 sections. Each one of them you could try or train for preparing some of the certificate resource definition. These two can also appear in CKS or even I would say in CKAD. Releases into the cluster. So here, so in case you don't remember all the help commands or just the command that they are asking to you to use, you can go to the documentation of Helm. Remember that you have some resources that are allowed to be consulted in the exam. So in this case, the Helm documentation is allowed. So you only have to go to documentations. And if you want to list the releases in the cluster, you will see that in the documentation, there's nothing that is talking about the releases. So in this case, you will have to memorize at a certain point the commands. So you cannot be totally in blank with the question, but you have to know more or less how the commands in Helm work. In this case, if we go to the Helm list, we will see that Helm list lists the releases. So remember that for some of the commands, they are not just as direct as we would like. In this case, if we type Helm list, we would have an empty list, and Helm list and Helm ls, it is the same. And here it says that we can use -a to get all the releases. And the solution is just to redirect the command to one of the files. The other website that I want to recommend you is Killer Shell. This one I even recommend it more than Killer Coda, but for this one you will have to pay in order to use it. The good point about the Killer Shell is that the questions that appear here are almost exactly the same ones that you are going to encounter in the exam. So this makes it the perfect website to prepare for your CKID exam. So let's go to see a little bit about what we can find here. They say that they give 22 complex question scenarios, and you will have 120 minutes to complete the exam. But don't worry, because you will have 36 hours to play with your sandbox. Basically, the functioning of the website is that they give you 2 sandboxes that you can activate, and at the moment that you activate one of them, you have 36 hours to play with that sandbox. And they simulate the exam by giving you 2 hours to complete it, but after these 2 hours complete, you can continue making or solving all those questions that you couldn't finish. So this makes it a perfect companion for those weekends in which you don't go out. More things that they show you in the website, for example, is that they have 22 unique scenarios with all the solutions. Then they give you the score. And one of the best points of this website is that they give you, or they provide you with a remote desktop that is exactly the same, the one that you are going to encounter the day of your exam. Remember that the remote desktop in the exam, it is somehow limited, and you will have to get used to, for example, the copy-paste action, getting used also to use an old version of Firefox and many other things. Also, if you still don't want to pay to see the service, there are some preview questions that are free. And here it goes the price. How much does the simulator cost? Remember that by paying this $30, you will have access to 2 sandboxes. Each of the sandbox has 36 hours. Here you can see in the dashboard how does it look like when you purchase some of the sandboxes. Here you can see how I completed one CKID simulator, and the other one I even didn't have to use it, so I could pass the certification without using the 2 simulators. Just for your information, both simulators have the same questions. So for example, you can try with one of the simulators, then go and do the first attempt of the exam, And if you don't pass it, you still have one more sandbox to prepare for that second attempt. The other resource that I encourage you to use are the Slack forums of Killer Coda and Killer Shell. Let's have a look to them. This is how it looks like, the Killer Shell Slack channel. You can see how there are different sections or channels for each of the certifications. In this case, we have like a
Docker just crossed 92% adoption among engineers. It's the most widely used developer tool on the planet right now. And yet, most developers using it every day are still doing it wrong. Wrong layer order, containers running as root in production, health checks that silently lie, and a whole new chapter of Docker most engineers have not even seen yet. If you're new to Docker, this video gives you the foundation you actually need. Not just commands to copy, but the mental model to understand what is happening. And if you have been using Docker for years, stay with me. There are habits most experienced engineers have not updated. And Docker changed significantly in 2026. Let's get into it. Imagine 3 engineers on a team. One is on a Mac, one on Windows, one on Linux. Each has a slightly different Python version, different library versions, and slightly different configurations on their machine. The app works perfectly on one machine and breaks on another. And in production, it behaves differently from both. And you have probably lived this. It's called the works on my machine problem. And it has frustrated developers for as long as software has existed. The first serious attempt to fix this was virtual machines. The idea is elegant. Divide one powerful physical server into smaller virtual ones. Each virtual machine gets its own dedicated slice of CPU, memory, and storage. And each one runs its own complete operating system. So if everyone on your team spins up the same virtual machine, you will all have the same environment. Problem solved. Virtual machines worked. They became the backbone of cloud computing. But they carry a cost. Every single VM needs gigabytes just for the operating system. And booting one takes minutes. So if you're running 5 services, you're running 5 full operating systems simultaneously, all consuming resources just to exist. There had to be a lighter way. And that lighter way is containers. And here's the difference. Look at the left side, containers. Multiple apps, each with their own libraries, but all sharing a single underlying operating system at the bottom. No duplication. On the right, virtual machines. Same apps, but each one sitting on top of its own full guest OS. A virtual machine image for a simple Python service can be several gigabytes. The equivalent Docker container is around 150 megabytes. A VM takes minutes to boot. A container starts in seconds. Docker is the platform that made all of this practical. Before Docker, working with containers required deep Linux expertise. Docker packaged the whole workflow, building, running, and sharing containers into something any developer could pick up. 3 concepts you need to carry through everything else. The image is a package snapshot of your application and everything it needs to run. Think of it like a USB drive with your entire app already installed. Read only, built once, used many times. The container is the running instance of that image. When you start a container, Docker adds a thin writable layer on top of the image where the app can write files, logs, temp data, whatever it generates at runtime. Stop the container and that writable layer disappears. The image underneath is untouched, ready to go again. The registry is where images are stored and shared. Docker Hub is the public one. Most companies also run a private registry for their own images. When you type Docker run in your terminal sends that to the Docker daemon, the background engine doing all the actual work. The daemon checks if the image is on your machine. If not, it pulls it from the registry. Then it starts the container. That is the full loop. To create an image, you write a Docker file. It's a plain text file with a list of instructions. Each instruction tells Docker what to do. Use this base operating system, copy these files, run this command. Docker reads it top to bottom and executes each step in order to build the image. Once you have a Docker file, you run Docker build and Docker produces the image. That image is what you ship. Now that you understand how an image gets built, let's talk about 3 things most developers are still getting wrong when they write that Docker file. The first one is layer order. And this single mistake is responsible for builds that take a minute when they should take 3 seconds. Every instruction in a Docker file creates a layer. Each layer is a snapshot of what changed in that step. The files added, the packages installed. Docker stacks these layers on top of each other to form the final image. And here is why this matters. Docker is smart about rebuilding. Every time you build, it looks at each layer and asks, has anything changed since last time? If nothing changed, it reuses the cached version and skips that step entirely. The moment it finds a layer that changed, it throws away that layer and every layer above it and runs those steps fresh. So look at this Docker file. Say you change one line in your application code and rebuild. Docker sees that copy changed, so it throws away that layer and everything above it, which means pip install runs again. Every package downloads and reinstalls from scratch. A 60-second build even though your dependencies never changed. Now flip the order. Same code change, Docker checks requirements.txt, unchanged, cache hit. Pip install, the sticker underneath it has not changed. Cache it again. Only the last copy reruns. 3 seconds instead of 60. Same output, just smarter ordering. And so, put the things that change least, your dependency files, near the top. Put the things that change most, your application code, near the bottom. That is the rule. The second thing most engineers get wrong is running containers as root. By default, if you do not say otherwise, your application runs as the root user inside the container. Root is the most powerful account on any Linux system. It can read, write, and change everything. So if an attacker finds a vulnerability in your application and gets inside the container, they are root. That is a much more dangerous situation than if they had landed as a regular user with limited access. 2 lines fix this completely. Add them just before your CMD. This creates a user called app user with no special permissions and switches to it. Everything your application does from that point runs with minimum access it needs. Nothing more. The third thing is the health checks that lie, and this one catches people in production. Docker can tell you a container is running, but running just means the process is alive. It says nothing about whether your application is actually healthy. A container can show as running while the app inside has lost its database connection, silently dropped into an error state, or is accepting requests but returning failures on all of them. From Docker's perspective, healthy. From your user's perspective, the service is down. A health check fixes this. Every 30 seconds, Docker calls your health endpoint. 3 failures in a row and the container is marked unhealthy. Any orchestration platform sitting above Docker, such as Kubernetes, ECS, Cloud Run, uses that signal to automatically restart the broken container before anyone gets paged. Just make sure your health endpoint tests something real. Database connection, cache availability, not just that the process started. Those are the 3 fixes that most experienced engineers have never been told explicitly. Now let's look Look at what Docker is actually doing in 2026, because this is the part most Docker tutorials have not covered yet. Now, you just saw how Docker builds work, and if you have ever run a multi-stage build on a real project, a compiled language, a heavy dependency tree, a monorepo, you know exactly what happens next. You push, you wait. You fix one line, you push again, you wait again. Sometimes 10-15 minutes per build. And that's not even counting the time your CI runner spends spinning up from scratch on every single run. The problem isn't Docker itself. The problem is that most CI systems treat every build as if it's the first build. No persistent cache, no memory of what already ran. Every job starts code. We'll stop at containers and compose. But Docker is not standing still. In 2026, it is becoming the default runtime for AI infrastructure. And three things change that are worth understanding. The first is how MCP servers work now. If you have been following AI tooling, you have heard of MCP, the Model Context Protocol. It is the standard that lets AI agents connect to tools and external services. One spec, any agent, any tool. Think of it as the USB-C of AI tooling.
Oh, well, folks, it's Sunday and we have a new OpenClaw release. So I just saw this pop up on my feed. I was just about to leave the office, but hey, if the OpenClaw team is not leaving, then I may either. So let's pop a cola and figure out what's new in the newest OpenClaw 3.8 update. Just outside looks here, it's not too much. So it mostly figures on their plugins, X integration, and ACP bindings. All right, so it's minor improvements onto their initial process. I have a breakdown here. Like there was a few breaking changes. I'll talk about that, but mostly it has to do with how it works with Grok. This is interesting. It's on Claw Hub this week.
Prepare to face justice!
Forget OpenClaw. And look at this. This is my 8-year-old phone, and I have transformed it into a fully functional 24/7 AI agent machine. The website you are seeing on the phone screen right now was entirely built by PicoClaw AI Agent. I did not write a single line of code. The AI agent handled everything from start to finish. And the best part? It runs on Llama, which means it is completely free. No expensive hardware to buy, no cloud-based platform fees, no subscriptions, just your phone, because PicoClaw is incredibly lightweight and designed to run on minimal resources. So stay with me, because I am going to show you exactly how to install PicoClaw, the powerful alternative to OpenClaw, and how you can put this AI agent to work for you, whether that is automating tasks or building websites just like this one. I have connected it to my Telegram and it works absolutely perfectly. The interface is as simple as it gets. You just type what you want and the agent immediately gets to work. You can assign it virtually any task, just like you would with OpenClaw, and this lightweight agent will execute it without hesitation. It is the kind of always-on AI agent that works for you around the clock. Before we jump into the installation, let me give you a quick live demonstration of just how capable this agent really is. I wanted to build a SaaS website, so I simply typed, "Build an aesthetic SaaS website, browse the internet, find relevant images, and use them in the design." And just like that, it got to work. You can see it writing HTML and CSS code in real time, building the entire layout on its own. Within just a few minutes, the website was completely ready. Let me copy the preview URL and open it in the browser so you can see the final result for yourself. And there it is. Look at that. It built a genuinely impressive website with almost no input from me. Now, I will be honest with you. It is not going to be pixel perfect out of the box, but here is the thing. The more detailed your prompt, the better the result. You can keep refining it just by describing what you want to add or change, and the agent will handle the rest. Now, let us get into the installation, and I promise it is much simpler than you might expect. To get PicoClaw running on your phone, you only need two things: the Termux app and the PicoClaw repository, which contains all the commands you need to run. I have dropped the links to both directly in the description below, so you do not have to go searching for anything. There is no complex setup here. It is purely copy, paste, and go. So open up the Termux app and let us get started. Once you are inside Termux, type this command, pkg install Ollama, and hit enter. This will download and install Ollama, which is what powers the free large language models behind PicoClaw. Once that installation is complete, run the next command, Ollama serve. This starts the local server that allows the AI agent to communicate and process your requests. Once the server is up and running, tap the three-line icon button inside Termux and open a brand new session. Inside this new session, run the following command, Ollama run Kimi-K 2.5. This will confirm that your Ollama model is up and running correctly. And just so you know, you are not limited to this specific model. I will include a link to the Ollama model library in the description so you can explore and swap in any model that fits your needs. Now, if your model launches without any issues, you are good to go. However, if Ollama presents you with a login URL instead, do not panic. Simply copy that URL, paste it into your browser, complete the login, and then rerun the same
So China's done it again. It has just taken OpenClaw and just made an extremely efficient and cheaper version that can run on a $10 Linux board or like an old Android phone. So what's the hype all about and what can we do about it? Let's dive into that in this video today. So just as of February 16th, so yesterday, it was made by a company based in Shenzhen. They've been making chips and like AI stuff since 2011. A company called Speed based in Shenzhen, which is kind of like the tech capital of China. And the creation of this isn't so much in the sense that, oh, this is going to be beating OpenClaw, but more on the speed of advancement. Like this could probably start running on a toaster or a Tamagotchi or even a potato in maybe 2 weeks or 1 month's time. God knows what it can run on by the end of the year. But if we take a look at this document here, I'll paste this link down in the description below so you can also reference this yourself. But it's pretty much a personal AI assistant inspired by Nanobot. And Nanobot is pretty much an ultra lightweight personal AI assistant inspired by OpenClaw, and it can deliver the core agent functionality in just 4,000 lines of code rather than 430,000 lines of code using ClawBot or OpenClaw. It's run on the programming language called Golang, and yes, it can run on a $10 hardware like an old Linux board or an old Android phone. OpenClaw is ran on the language TypeScript Node.js, while PicoClaw is ran on Go, and the RAM required is usually more than 1 gigabyte. So a lot of people are saying, oh, you can only run OpenClaw on a Mac Mini, but that isn't the case. You can run it on a VPS for way cheaper than that. But for PicoClaw, the RAM required is only less than 10 megabytes. And the startup time to make it work, no, any $10 to $50 Linux boards will work. A Raspberry Pi, also step, and for that, then comment down below. Cycle is a loop. So Linux board. Now the common misconception here that I see on Twitter right now, the $10 and sends it back, and that's why it can be make a phone call or a tool call in our instance, get an answer, think again, maybe make another call or call another tool, and then write you back on the email or just go to your desk and tell you about it. That whole process is one loop. Now, PicoClaw and OpenClaw both do this exact same thing and both do it on the exact same desk routine. The only difference is that PicoClaw uses a smaller desk. Another example is that OpenClaw is built on TypeScript or Node.js, while PicoClaw is built on Go, which is more like a stripped down version of that code. So OpenClaw is kind of like installing a kitchen to make coffee, while PicoClaw is just using a kettle and a mug. They both make the same coffee, just with way less stuff around it. And 95% of PicoClaw's code was written by an AI agent. And this is pretty interesting because that AI literally rebuilt itself to a lighter version. So if we take a look at the real cost breakdown here of PicoClaw and OpenClaw, like a lot of people are saying, oh, you should go with a $600 Mac Mini M4, which you don't necessarily need, but it's just, you know, maybe safer in most people's eyes. But PicoClaw is $10 to $50 for a board. AI calls remain exactly the same because it just depends on your LLM that you're using. For web search API, they're both free using Brave. It's around 2,000 calls per month. They both require you to communicate with them through Telegram. WhatsApp just doesn't work on PicoClaw, and the total year's cost is around $959 to $1.5K for OpenClaw. If you're using a Mac Mini, it's probably way cheaper than that if you're using a VPS to start off. And when you're first starting off, I do recommend you using a VPS to start off because that allows you to learn much cheaper. And then once you've learned and started automating some tasks, then you can switch over to a Mac Mini or a Mac Studio. So what the GitHub community is reporting is that for just light usage, like a few cron jobs, it's around $10 to $30 per month with API costs. Again, if you want me to run over token efficiency and credit efficiency video, comment down below and I'll be sure to make that in the next video. PicoClaw will be probably best for light work. It's just basic daily briefing, simple tasks. You don't need OpenClaw to do that. But for business automation, complex research, and competitive analysis, then I recommend using OpenClaw to do that. So kind of like a hybrid structure or like a smart architecture to go through is kind of like having both. Like the optimal setup will have both. So the cheap always on board will require you to have the PicoClaw, $10 to $50 a month, using the PicoClaw agent, using the Go language, cron jobs, Heartbeat, Telegram jobs, just basic research and stuff like that, and basic communication and basic cron jobs. PicoClaw would do the job, but keep the Mac Mini and keep OpenClaw for browser automation. Like if you need to operate some fancy software, which requires OpenClaw to understand the step-by-step on how you operate that software, you should definitely stick with OpenClaw's full feature set. So let's take a look at what the community is saying as well. So we can also take a look at PicoClaw's website here and take a look at the comparison. Pretty much what we went through just now, less than 1 second to start up, while OpenClaw is around 30 seconds to 500 seconds. And they say, yeah, the minimum cost is 500 plus for a Mac Mini, but you do not need to use a Mac Mini to start OpenClaw. And here are a few use cases you can use for PicoClaw. It has code assistant, content creation, API integration. So if you're just using some basic API
The release of Minimax M2.7 is drawing attention especially for agentic use cases like OpenClaw. But there are also other interesting topics to go through, like China being compute constrained, what Minimax calls self-evolution, and really the broader market impact of the AI industry. Welcome to Kilobytes Code, where every second counts. China is certainly falling behind in terms of total compute availability. And it's not just the sheer number of compute that's shown here, but it's really the type of compute that China has in comparison to the US. For example, the best GPU that US sells to China is the NVIDIA H200, which recently went into production again to sell to China. And the H200 is still based on the old Hopper architecture, which is 2 to 3 years behind in technology. And here in the US, hyperscalers like OpenAI, Oracle, Meta, and even CoreWeave are now gearing up to use the new Vera Rubin chip. And as you can see, the inference efficiency we get in comparison doesn't even match. But when we are looking at Minimax M2.7 release, the market that Minimax M2.7 serves is the 50 to 100 tokens per second section on the market. And the Hopper architecture is still viable. Minimax M2.7 is being served at 50 tokens per second in speed, which is right in this chart. And their high-speed version that charges 2 times in cost is likely offered at a max of 100 tokens per second. As you can see, Chinese labs have this compute wall they face in inference where in order to scale beyond 100 tokens per second while using the Hopper architecture, they have to at least double their capacity to maintain their service level agreement. While being on Rubin chip, scaling out doesn't actually come to a huge cost in throughput. In other words, the x-axis here that shows the tokens per second per user or interactivity, and the y-axis here that shows the throughput in total number of tokens generated, assuming a megawatt data center. What you're seeing here is the immediate scaling limit that Chinese labs face as they are already few generations behind in GPUs. Now, while this chart certainly seems doom and gloom, the demand for compute at this band is actually growing largely because of OpenClaw. For example, if I keep Minimax M2.7 running for 24/7 for an entire year, given the current pricing per million output tokens, the total annual cost to run this is around 2,000.
What you're looking at right here is my mission control center. You can see I've got 7 agents enabled. I've got 5 tasks in progress. You can see what all of them are doing right here. We can see all of the recent activity and all the tasks, and in my inbox, I can see what is needed to be approved by me or what I have to look at. Down here, you can see the 7 different agents we have, and you can see what they're actually working on. So right now, the AIS marketer is running. And for each of our different agents, we can control their instructions, their skills, their configuration, everything. So now in a matter of 30 minutes of me coming in here, acting as a board, which means I'm giving them high-level goals, metrics, things that I want to achieve, but I'm not actually sitting in the business being an operator. I have this entire company now. I have a CEO, I have a social media agent, I have a marketer that manages a copywriter, a strategist, a designer, and a researcher. And this is all thanks to a combination of Claude Code and this tool right here, which is called Paperclip. So by the end of this video, you guys are going to see exactly what this tool is, how it works, and you're going to be able to either set up a brand new company right now with no human employees, just you, or you're going to be able to build a team around maybe a portion of your business. So for example, right now with my Up at AI business and AI Automation Society, I'm not going to come in here and automate everything and go fire all my employees. But what I did here is I can automate a portion of it and then slowly just kind of like chip away more and more, expand this organization in here, and maybe grab a different subunit from my business and try to make that completely AI first. You can see they're sending me notifications down here. I could come in here and I could create new issues whenever I want. And I can say, hey, this is for the AIS designer and this is for the LinkedIn content strategy project. Here's what I need you to do. Here's the high level goal. Work with the team and just figure it out. So if this sounds like something that's interesting to you, let's not waste any time and get straight into the video. So the tool that we're talking about today is called Paperclip. It is completely free. It's an open source orchestration for 0 human companies where you can literally have your AI employees hire other ones, set goals, automate the entire business. You can see on the GitHub that they just hit over 36,000 stars, and this has only been out for a few weeks. You can bring in your own agents. So if you've already set up some custom, OpenClaws or Claude Code things, you can bring those in. You set goals. There are heartbeats, so it can actually just be waking up and checking things all the time. You can set a specific budget per agent. So if I come to the dashboard and I go to the, designer, for example, I could come in here and just make sure that the designer is only using a certain amount of my money per month, which means every single one of our agents, we can see exactly how much money they're actually spending. Now, the reason you guys are seeing 0 here and on my dashboard is because I'm using my subscription. So if you're using something that is actually pay per token, that's where you get all of the spend analytics. You can run multiple companies inside of Paperclip. So if you see on the dashboard over here, I've got this AIS, but I could go down here and just add a new company and add a new company and just keep doing different things. And so that's where maybe if you wanted to start up a new idea, then you would start a company for that. But if you wanted to integrate some different like teams into an existing business, then maybe you could just do different departments in here and completely automate those. So for example, with this company, this is part of AIS, and the overall goal I set here is, we have a community called AI Automation Society. It's got over 300,000 members, but we want to scale the content efforts around the community and scale, like the brand around this that doesn't rely on me and my personal brand. So that's what I'm going to be doing here in Paperclip. It's got a ticketing system, so everything is logged, every conversation, every issue. If I go back to my dashboard here and I go down here, we can see all the activity and all the tasks. And I can open these up, I can leave comments, and I can see what they're thinking and what they're actually doing in here. And in this specific one, you can see what it was doing is it was creating some carousels. This was its first try, so I'm gonna have to go back, but very cool. And like I said, you can use this with OpenClaw, Claude, Codex, Cursor, whatever you want. In today's example, we're gonna be talking about using it with Claude Code. So I know I was just clicking around and I showed you guys a ton of stuff. That's just to sort of get you in the mindset of what we're going to talk about today and how it works. Let's take a look at what we're actually looking at with our agent configuration. Right here, what we can do is we can assign it. And this is basically just going to be like my partner in crime when I need help doing something with Paperclip. Because the way I feel, build a plan and to assign some work to it. You can see the CEO just started up a bunch of tasks, and now the engineer has a repo. I'm going to go back into the dashboard here, and I'm just going to paste in that skill and click add. Different the way you actually interact. It's much less like having a long ongoing conversation. I can't assign it to the QA agent because I haven't yet approved that. You can see it's in my inbox. So let's just for now go to the CEO. It should be a Paperclip company section. This is pre-built company templates that you can import into Paperclip. So if I click on this, you can see now as we scroll down, we have a growing catalog of ready to deploy agent companies or agent orchestrations that we can just put in. So we have GStack, we have superpowers, we have agency agents, we have all of these different things that we can actually just import, and it comes with agents, skills, knowledge. So for example, with GStack, it comes with a CEO, a CTO, a QA engineer, release engineer, staff engineer, and all of these skills are already in there. And there's so many different ones that you can browse, whether you want to have an AI agency, whether you want to have some sort of autonomous AI intelligence company. This one is specialized for scientific research, and there's all of these different types of, employees with specific knowledge. You can see these are named after actual doctors. So anyways, I just wanted to show you guys that if you wanted to get in there and play around with it, it's definitely a cool way to start from, like 50 rather than just starting from 0 and building out your own team. You could just bring in a team. Like this one has literally 48 agents, which is crazy. So at this point, we still have these agents running for us. We still have, the QA agent just finished something up. I could check the inbox here and see what's going on. And if you wanted to have them keep working on stuff, once again, you'd make a new issue, or you could just comment and they would wake up, read your comment, and keep going. So if they have anything where they have like a specific blocker or they need something from you, they will ask for it. Now, the final thing I wanted to talk about was secrets or API keys. And what you'll notice is there's not really a spot in here